Tracealyzer provides visual trace diagnostics for developers of RTOS and Linux-based embedded systems. This allows for recording and visualizing the software at runtime. For multitasking embedded software, the source code does not give the full picture of the runtime system. Visual Trace Diagnostics gives you a detailed timeline of the runtime system and a large set of visual overviews, metrics, and statistics. The data collection relies on a software library with very few hardware dependencies, so it works on essentially any processor and doesn't require any extra hardware. It allows for continuous live streaming of trace data from the target system to host, so you can monitor the system over long periods of time. You can even see live animated views of the data. Let me show you what live streaming looks like. We just click Start Recording and Tracealyzer begins to receive, process and visualize the trace data in real time. On the left you see the trace view showing the execution of RTOS tasks and interrupts. This application is a PID motor controller and we can see the control signals in the bottom right view. Target position, actual position and motor torque. These are variables in the code that we are logging with Tracealyzer. While software tracing isn't anything new, raw trace data is quite difficult to use in practice. Viewing this in a text editor isn't very helpful. You get large amounts of low-level events where most are irrelevant repetitions of the same patterns. You can't see the forest for all the trees. To really benefit from software trace data in everyday development, the solution needs two more components. The data needs to be processed into a meaningful model describing how each event affects the system state. The data needs to be visualized to allow quick intuitive comprehension and actionable insights, even for large datasets. The human brain is visual and excellent at pattern recognition. We can leverage that by showing visual overviews from different perspectives. By connecting the views, we allow for a top-down workflow that is ideal for system-level analysis. Spot anomalies in high-level overviews and drill down to inspect the details. We call this Visual Trace Diagnostics. This is useful for debugging purposes whenever you need a timeline for your software. This is often the case when debugging a full multitasking system, and especially important when the location of the bug isn't obvious from the symptoms. This means less debugging time and more time available for customer value creation. Another important use of Visual Trace Diagnostics is to find software design flaws. They are not necessarily functional errors, but they may reduce performance and responsiveness, increase the risk of future bugs, and make the system testing less effective. With Tracealyzer, you can easily identify design flaws like excessive dependencies between tasks, unsuitable task priorities, and variations in software timing, so you can fix them early and avoid later problems. Last but not least, Visual Trace Diagnostics can be used to measure software timing and resource usage. This way, you can verify real-time requirements and keep track of the software performance and resource usage throughout the development project. In short, Tracealyzer is the leading solution for Visual Trace Diagnostics and provides several important benefits. Easier debugging of system-level issues, finding software design flaws, and verification of timing and performance. This saves time and money by less debugging time, reduces the risk of project delays, improves product reliability and performance, and frees up developer time for important customer value creation. It works on essentially any processor and no extra hardware is required. To get started with Tracealyzer, click the download button on percepio.com and sign up for an evaluation. If you have any questions, feel free to contact support@percepio.com. Thank you.